Here's a differential equation that looks like an exact differential equation, but it's not. If you check for exactness, you get 4x from the y derivative of the coefficient of dx, and the coefficient of dy, if you differentiate by x, you get 1, so they're not equal. So what do you do in that case? Well, one idea is to assume that you can multiply some function to this equation so that it becomes exact. So let's just assume that there's some function f of x that you can multiply to the above equation, and somehow this will become exact. In other words, if you take the derivative of x squared fx plus 4x fx y, if you take the derivative of this function by y, which is this one, right? And that gives you 4x fx. On the other hand, if you take this one and differentiate by x, well, it's a product of two functions of x, so you need to use the product rule. And then you get f of x times 1. And what we require is that these two has to be equal. Let's write down the condition and see what we can do. Now I can move this to the other side and make it as 4x minus 1 times f of x equals to f prime of x. And from here I can divide by both sides by fx and also by x, and you get rid of f of x completely on the left side and x is gone, and if you look at the resulting equation, you have f prime of x over f of x equals to 4x minus 1 over x. And actually, although you still don't know what f is, we can integrate both sides without any problem. Why so? Well, we know that f prime over f integrates ln of the denominator, right? So this left side just becomes ln of the denominator. On the other hand, 4x over x is just 4, so integrating 4 gives you 4x. And negative 1 over x integrates to ln of x. And because we just need to find one function that works, you can just put c as 0. You don't need it. Now what do you get if you solve this for f of x? It's ln of f of x equals to 4x minus ln of x. Exponentiate both sides, and then e and ln cancels, and minus in the exponent becomes division, right? And again, e and ln cancel, so you have e to the 4x over x. So now let's check if this does make the differential equation exact. So multiplying that to everywhere, this will cancel with that, so those two x's will cancel, and actually x squared divided by x is x, and this x will also cancel, and you end up with x times e to the 4x plus 4 times e to the 4x y dx plus e to the 4x dy. In other words, if you take this differential equation, you can see that they're all divisible by x, right? So you can divide by x and then you multiply by e to the 4x. The resulting equation is x times e to the 4x plus 4 times e to the 4x y dx plus e to the 4x dy. Now let's check if this is exact. If you take the first element and differentiate by x, actually differentiate by y, sorry, then this becomes 0, whereas the second one just gives you 4 times e to the 4x. On the other hand, if you take the second one and differentiate by x, you get exactly e to the 4x times 4 because of the chain rule, and they are indeed equal. So it's exact. Awesome. Now that it's exact, we can proceed by integration. So f must be the first element times y integrated by dx. Okay, and this one will require a tabular integration. So plus minus d integral, and you're trying to differentiate x and integrate e to the 4x. X differentiates to 1, 1 differentiates to 0. 1/4 e to the 4x and 1/16 e to the 4x, plus and minus and plus, and that gives you the integral as 1/4 x e to the 4x minus 1/16 e to the 4x. This one is simple u substitution, and it just gives you e to the 4x y and some function of x, which I'll call as g, some function of y, which I'll call as g of y. And because the derivative of this function with respect to y has to be e to the 4x, let's try to differentiate this by y. You get just e to the 4x plus g prime of y, right? And that has to equal to e to the 4x. So g prime of y could be just a constant. And that means that this function actually satisfies this equation. Okay, so if you take this and differentiate by x, you get the first part, and if you take this and differentiate by y, you'll see that it exactly produces this much, and therefore the final answer would be fxy equals to 1/4 x e to the 4x minus 1/16 e to the 4x and plus e to the 4x times y.